So it says if the stress on a wire is 107 Newton per meter square and the wire is stretched from its original length of 10 cm to 10.05 cm, the Young modulus is what? Young modulus is stress over strain, and Young modulus is stress over strain. So in the question, which one is the stress? Which one is the strain?
That's about seven stress.
Is the stress. That's force over area, right? Stress is force over area, right? And that is Newton over meter square. That's why you can see Newton per meter square, okay, in that unit, which is otherwise written as Newton meter raised power minus 2. Just take note of that because that is stating the formula for stress. So the strain itself is extension extension over original length. So to get our strain, we need to get the extension. The extension is new length minus original length. That is 10.00. Then over original length, which is 10. So we have 0.05 over 10 as the strain. Okay. So what is 0.05 divided by 10?
Hold on.
0.05 divided by 10 will give us 0.005. 0.005. That's our strain. So we have the stress given, which is 107.
See more than seven.
107
What is 10 raised
over
to the minus 6?
0.00. Who is talking there?
I thought it was 10 raised to the minus 7.
10 raised to power minus 7. Well, it could be 107, it could be 10 raised to power 7, not even minus 7, okay? Is that clear?
Yes, sir.
Not minus 7. That minus does not affect this. So I think this is 10 raised to power 7 in the question itself. Hold on. Let me see. Not 107. So that, because if we use 107, definitely we are going to get a different answer. So let's make it 10 raised to power 7. That's from the question. So this one now is going to be 10 raised to power 7, which is the same thing as 1 and 7 zeros. Okay, let me see. That is 1, 1, 2, 3, 4, 5, 6, 7 over 0.005. which this one is 5, you know, if I turn this to 5, then I had three more zeros above because 1, 2, 3. So I can now divide and say 5 here 1, 5 in 10 is 2. Then the final answer is going to be 2 with 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros.
Did you not do this like
So this is
the
going to
same
be
thing? Same thing.
2 times, who is that one talking? This is going to be 2 times 10 raised to power 9. Um, Not 10 raised power 8. So if these are the two in the option, one will make you fail the answer, one will make you get the correct answer. I mean the mark, okay? Is that clear? Can you hear
Yes,
me?
sir.
So,
Yes, sir.
though you can say, yeah, yeah, it's very close, but very close doesn't get the mark, okay? Okay?
Yes, sir.
So, in order to get the mark, you have to get the accurate answer. And let me check on something here. Newton per meter square divided by, okay, that means the unit is still going to be Newton per meter square because the strain has no unit, okay? Newton per meter square. Is that clear? Is that clear?
Yes, sir.
Why did I say the strain has no unit?
Yes.
Why does the strain has no unit?
Because extension of the original is the same
Because
as
the
it.
extension is in maybe meters or centimeter or anything, and the other one is also in the same unit, which is the original, and then the unit cancels, so it's left with. If it's WAEC or GC, if you refuse to put your unit, you still fail it. Your mark will be deducted. Is that clear?
Yes, sir.
But if it's jam that is objective, you could easily see, oh, 2 times 10 raised power, whether unit or not, you nobody cares, okay? Because the unit will be in your options. All right? Is that clear now?
Yes, sir.
Okay. So the next question is going to be for Messi. Let's see. Number two. Let's see this one. So Messi, read this out. Let me hear. Then you try it a little bit.
A solid weight 10 Newton in air, 6 Newton when fully immersed in water, and 7 Newton when fully immersed in a liquid. X. Calculate the relative density of the liquid.
Okay. So
Start.
yes. What do you say?
and to be sorry,
What do you call it?
some English.
Okay.
I didn't see this. Pastor, could it be 3/4?
Is that your answer?
Yes.
So, how did you get 3 over 4?
Usually for related density, weight in air is weight in air minus weight in water. Weight in air is obviously weight in air is high, so weight in air minus weight in water over weight in air minus weight in
Or maybe what you wanted to say is loss in weight in the given liquid, then over loss in weight in the other in water, right?
yeah,
That is upthrust in the liquid over upthrust in water. And that would be 10 minus 7 over 10 minus 6. Okay? 10 minus 7, 10 minus 6. And that will give you this is 3 over 4. Okay? So, just in case if it's a theory, you will go beyond just getting the answer, but the explanation too. Okay? Is that clear?
that's
Um, the next one is for Sarah. So, that 3. So, we want to know what will happen to the surface tension of a liquid as its temperature increases.
surface tension decreases.
Decreases, right?
Yes.
So that's correct, but why? So it decreases. Let's put that answer. It decreases. So if you are asked to explain, maybe why will this, or what is surface tension itself? What is surface tension? Yeah. Does any one of you know what is surface tension? Okay. Um, Surface tension is the property of a liquid that makes the surface to act as if it were stretched or like it's an elastic material. We can say it is the tangential force that acts across the surface of the liquid. And also, we can say this is the ability of the liquid to act as a stretched elastic, skin, like a skin, when it is formed by the bonds between or the bonds among the molecules of the liquid. So When the temperature of the liquid increased, these bonds that is forming like elastic stuff is gonna break because energy is needed to break bonds and to form new bonds, right? Right? Do you remember we talked about something in chemistry yesterday, talking about energy in reaction, right?
Yes.
Okay, so if the temperature increase, it will break the bond, then the skin or the force or the surface tension that is there will become weaker, and with that, it will be reduced. That is why when you boil or eat a substance, it reduces the surface tension of that liquid. Okay, is that clear?
Yes, sir.
Okay, so the next question is going to be for Taiwo, which is Thai. C number. Okay, C number 4. So you're gonna check this. This is peanut. Okay. Um, this one, because it involves a sort of proofing with no given values, so I'm going to bring up options to this one. Okay. So let's see. But whoever is talking, you're going to explain how you arrive at your answer. So we'll say, according to Boyle's law, P1 V1 equal P2 V2 at constant temperature. That's pressure 1, volume 1, pressure 2, volume 2. So from this particular question, our P1 equal P naught. Then our V1 equal V naught. Then it says the pressure is compressed to one fifth. I mean, the volume rather. A gas at a volume V naught in a day is compressed to one fifth. Then we're looking for the pressure if the temperature remains constant. So that means V2 is 1 over 5 of V1, which is the V naught. So we're looking for P2 now because we've been given, now we have P1, V1, and V2. Now P2 is unknown. So if we make P2 the subject of the formula from this, we have P2 equal to what? P1 V1 over V2. Okay, is that clear?
So,
Then P1 is P naught, while V2 is V naught. Okay, I mean V1 rather is V naught. Then V2 is one fifth of V naught. So here V naught can eliminate V naught. Then we now have P2 being equal to the P naught divided by 1 over 5. And this is going to be P naught times 5 over 1. And this will be 5 P naught. Is that clear?
so
But before any other thing, let us try to verify something. That is the answer anyway, but I want us to verify that definition, Boy's law here. V1, P1 V1 equal P2 V2. Let us assume that this is 4 times, at pressure 4, the volume is 10. Then I reduce the pressure to 2. What should be the volume? If this is 4 times 10, 4 times 10 will be 40, yes or no?
yes.
2 times what will give me 40? 2 times what will give me 40? 2 times what will give me 40?
20.
20. So that means what we have here is that 4 times 10 equal 2 times 20, right? Right? Now, what happens to the pressure? The pressure reduces, right?
Yes.
And what happens to the volume? When the pressure reduces, the volume increases, right? Right?
Yes.
Now, is that a direct proportionality or inverse proportionality? Hmm? When something is direct, because of the definition you gave, Moses, that's why I'm going through this so that everybody can learn. Give me that your definition of Boy's law again.
Volume of the given mass of gas is directly proportional to its pressure.
Okay, if it is directly proportional to pressure, if volume is directly proportional to pressure, it means as volume goes up, pressure should go up also. But in our experiment here, we observe that as volume is going up to 20, pressure reduced from 4 to 2, right?
Yes.
Then the volume increased from 10 to what? 20. And it makes sense if you try to check it out. Let's see. Let's assume this is a container of gas. You know, gas used to take up I mean, the volume of its container, right? Right?
Yes.
Now, let me now try to, you know, hold on. I want to repeat this particular structure. These are two containers now with the same amount of gas, the same volume, okay? So if I
Yes, sir.
now decide to I decide to compress the second container. I want to compress it, trying to reduce the volume, okay? If I reduce the volume, there's not going to be anything at this upper part, right? Right? All of the molecules at the upper part will mix up with the molecule here. Is that clear? Is that clear?
Yes, sir.
Then there will be so many here. Okay? So as there are so many at this place, what becomes of the pressure? What becomes of the pressure provided it's at constant temperature? The pressure increases here, right? Right? Can you hear me?
Yes,
Yes,
sir.
sir.
So here we say low pressure, high volume. Okay? Then here, what is it?
High pressure, low
High pressure, low or small volume.
volume.
Okay? Is that clear?
Yes, sir.
Let's say small volume because the volume has been reduced. So that means that definition of Boyle's law should be changed. Don't state that in an exam, okay? Boyle's law is a gas law that states that a gas pressure and volume are inversely proportional at constant temperature. Do you all get that?
Yes, sir.
When something is directly proportional, if it varies directly, as one increase, the other should increase. Okay? All right. So the next question is going to be for Moses, and that will be number 5. So you need all of this for any kind of O level, because they might bring the concept and ask you to explain in a exam. So let's see. Fine. Um, okay. Moses, read this.
A piece of substance of specific heat capacity, 450 joules kilojoules per Kelvin, falls through a vertical distance 20 meters from rest. Calculate the rise in temperature of the substance in hitting the ground when all its energies are converted into heat. Take
Okay.
it to 10 seconds square.
Okay. Now, so what do you think? Okay. So the question says a piece of substance of specific heat capacity. That's not head capacity. Heat capacity. Let me put T there. Of 450 joule per kilogram per Kelvin, falls through a vertical distance of 20 meters from rest. Calculate the rise in the temperature of the substance on hitting the ground when all its energy are converted into it. So, rise in temperature is what we're looking for. That is delta theta, the change in theta. At the height, at the height, the energy is mgh. Then when it's converted, it will be converted to heat, converted to heat, heat energy, and we have mc change in theta. So that means mgh has been equal to mc change in theta. Since it's the same object, the mass can go. Then we have gh equal to c change in theta. Then here, change in theta will be gh over c. So what is the force of gravity is 10. The distance is 20. The specific stuff there is 450. So here 10 cancels this, and we have 20 over 45. Like I said, you should leave your answer in fractions. So 5 here 4, 5 here 9 degree Celsius. Is that clear?
Yes, sir.
So conversion of energy from the potential energy has been converted to heat energy. Okay, let's go through the next question, which is for Messi. This one, I'm gonna have some options given, which is going to be, let's see, number 6. Just hold on there. These are some statements, and these are the options. So, Messi, read this and let me hear.
Which combination of the above are peculiarities of the boiling point of the liquid?
Wait a minute.
Liquid.
Hello, wait a minute. I said read the question, read the whole statement.
The question is down, then this thing is off.
The what?
Then one. The question is down, the
Mm-mm,
bottom.
mm-mm, mm-mm. Is this not part of the question? Bele? So read the whole thing. Thank you. Start from the beginning, number 6.
Okay. A liquid boiled when its saturated vapor pressure is equal to the external pressure.
Mm-hmm.
2. Dissolved substance in pure water leads to increase in the boiling point. 3. When the external pressure is increased, the boiling point increases. Dissolved substance in pure water decreases the boiling point. Which of the combination above are pregnant for boiling point of the liquid?
So, mhm. So what do you go for?
Yeah, the last one. This one. Substance in pure water because it is not substance in pure water but some liquids. Which is possibly considered.
So what do you go for? Hmm?
One, not to be student, don't substance in pure water. One, so I want to do.
One, two, three. Yeah. One, two, three. That's correct. That's option A, right?
Yes.
It.
Right?
Yeah.
So that means a liquid boils when its saturated vapor pressure is equal to the atmospheric pressure. Okay?
Yeah.
I said it's equal to what?
Atmospheric pressure.
Which is the same as the external pressure. Take note of that because if they ask you to define boiling point, don't put external pressure. You might lose some mark. Okay?
That's right.
Dissolved substances in pure water lead to increase in the boiling point of the pure water. Not only pure water, but almost any substance. Then,
Substance.
when the external pressure is increased, the boiling point will increase too. If they ask you a question and they say, under what condition will water, okay, what is the boiling point of water?
100.
Okay, under what condition will water boil above 100 degree?
Mm.
Sorry, please.
I should repeat the question, right? Under what condition will water boil above 100 degree?
When the external pressure is applied,
When the
when
what?
above external pressure is applied.
I can't hear that.
When external pressure is applied, when above
Is applied, right?
normal voice. Yes.
What do you mean by applied? External pressure, if external pressure is increased, okay, increased. Is that clear? Then it might boil above 100 degrees. But on a normal, on a normal day, on normal ground, all things being equal, water boils at 100 degree. Then the fourth option says dissolved substances in pure water decrease the boiling point. Of course, it won't reduce the boiling point because um, the impure substance will only, it will alter, it will not allow it to boil at the exact boiling point, exact temperature. It's going to increase, it's going to delay the boiling point because that the impure substance has to be catered for before it can reach its boiling point. Okay, that is where we'll be rounding up for today. Okay, so if you look through all of this, it is signaling to you that you should study Hooke's law and anything related to Hooke's law. Okay,
Yo.
is that clear?
Sir.
Take note of that.
So,
Maybe you should jot it down. Then this one, study relative density, study Archimedes principle, law of flotation, anything that has to do with that. The first one said Hooke's law, whatever has to do with Hooke's law,
how
like
this day for you too?
force extension,
You
stuff.
should. Hmm?
Then the next one, temperature. Okay, study about surface tension and frictional forces. Okay, they could ask you question in another way that will, that will involve you explaining. So just take note of that. Then this one, study the definition of gas laws. Okay, gas laws. Yeah, can you hear me now? So this one, study the definition of gas laws, then their relationship, like general gas law, like Boyle's law, Charles law, and so on. Then that will cater for this. Then this one, study heat capacity and specific heat capacity, everything about heat energy. And finally, this is still, you can try to know boiling point of certain liquids. Okay, like what's the boiling point of alcohol?
Minus.
What did you
Minus
say?
something, sha. 200. Minus
Minus what?
100. Minus 4. No. Is it 27? Minus something.
Mm, where did you get that?
Yes.
Alcohol boils at
Is it minus 4?
78.37 degrees. So boiling point of alcohol is 78, okay? 78 degrees Celsius. Is that clear?
78.
Okay. That is the example of that family is ethanol. So ethanol boils at 78.37 degrees. So let's just say alcohol boil at 78 degrees. So all right, we'll be running up there for today. And we'll meet on Tuesday by God's grace.
Thank you, sir.